Hi, welcome back. So we're going to talk today about operations on sets. So the first one's called a union, and I don't know your position on labor unions, but they kind of give you the idea. A labor union has people coming together for a common cause, so they bring all the things together. So the union of two sets is another set. It's the set of all elements that are either in A or in B. Another way I think about this is I have A and B are these cardboard boxes with items in them. The union would be taking a new cardboard box and dumping everything from set A and set B into the new box and just throwing the old boxes away if you like, or just thinking about them separately. So if you have a member in the union, it could be a member of A, it could be a member of B, or it could be in both. So here we have an example. A is the set 1, 2, 3, 4. B is 2, 4, 6, 8, 10. And the union is going to be everything that's either in A or in B. So A union B has to have 1, 2, 3, and 4. But it also has to have 2, 4, 6, 8, and 10 as members of A union B. So one way that we get good pictures is we draw what we call Venn diagrams. And I apologize. I have been trying really hard to draw Venn diagrams and I have not been able to do it. So basically what you have is you have a rectangle. The rectangle is called the universe and it basically tells us the context. So for example, if I were talking about different kinds of numbers, maybe all the real numbers would be the rectangle, or what I've put here on this page is I could have the universe as the set of all dogs, and that circle, which used to be orange and now looks kind of dark brown, it's the set C of all chihuahuas. Now notice that chihuahuas are dogs, so the universe isn't just the stuff that's kind of greenish, it's the whole rectangle inside the circle, outside the circle. But all the chihuahuas are pictured inside the circle. Normally, every Venn diagram should have a label for that rectangle in the lower left corner. We call it U for universe. There should be a label somewhere outside but near that circle that says C, the name of the set of all chihuahuas. And so what would I get for A union B? Again, I've tried to get you a Venn diagram. This is some clip art. It did not label the universe, so I don't really love it. However, you can see here that A is the entire circle on the left. B represents the set B is represented by the circle on the right. And that kind of footballish shape in the middle is both in A and it's in B. A union B is all of the purple, stuff that's in A, in B, or it might happen to be in both. The second kind of set operation is called the intersection. The intersection of two sets is the set of elements that are in both A and B simultaneously. So here you see a Venn diagram. Again, the universe is not labeled. The intersection is labeled properly. It's kind of a medium purple fuchsia kind of color. The A is two pieces this time in this Venn diagram. The one that has the A in it and the one that has the A intersect B. Together, that whole circle represents set A. On the right, the pink and the piece that's labeled A intersect B is all of set B. And the thing that says A intersect B is, again, the things that are in A and B both. That's the intersection. My favorite analogy is that the intersection of two roads is the part that's on both roads at the same time. Set difference. So if I write A minus B, I want the stuff in set A that's outside of set B. Set A is the whole circle on the left. But A minus B would be the part of the circle on the left that is not in the intersection. It looks like a cookie with a bite taken out. I could also do B minus A. That would be the right circle, B, with the bite taken out. And finally, our last set operation we're going to use is called the complement, and it basically means everything outside of the set, but in the universe. And here, if you want to talk about the complement, it's important to know what the universe is. If the universe is all the dogs, and A is the set of Chihuahuas, then A complement is the set of all dogs that aren't Chihuahuas. But if your universe is the set of all animals, the complement of A is all of the animals that aren't Chihuahuas. So know your context if you want to find a complement. So I've made some examples. I am going to take as my universe the numbers from 1 to 17. C is 1, 2, 4, 8, and 16. D is 1, 4, 9, and 16. I'd like you to make sure that you understand the ideas of union and intersection and set difference and complement by calculating these before you go on. Okay, hopefully you've got them all down. And so here are the answers. So C union D, remember what we're going to do is throw all of those elements together to form a new set. For the intersection, we only take the items that are in both. So for example, 2 is only in C, not in D. So 2 is not in C intersect D. C minus D are the members that are in A, but not in D. And D minus C is all the stuff that's in D when I cross off the stuff that's already in C. And C complement is all the numbers from 1 to 17 except for the ones that are 1, 2, 4, 8, and 16. Hope you did great. All right, the next one, when I got to a Venn diagram illustrating 3 sets, the drawing was very overwhelming. I tried for quite a while, so I am going to send you right now to a web page. It has a lot of good Venn diagrams at the top in a table, and below the big table, they have a very nice Venn diagram for A union B minus C. So I'd like you, if you would feel brave, to draw the Venn diagram illustrating A union B minus C. If not, you can go directly and take a look. And you'll notice that I'm very supportive of their efforts. They break it down into smaller pieces, just like Polya would. So they're going to draw B minus C, they're going to draw A, and then they're going to draw the final answer taking the union. So again, stop and go online. So we usually read intersection as and. I find it very helpful to read it as but or but in. So if I write A union B intersection C complement, I would rather read it as the elements that are either in A or, that's the union part, they are in B, but outside of C. So A union, the quantity B intersect C complement would be a very mathematical way of reading this, but you could also say it's the stuff that's in A, or it's in the set B, but not in C. So let's take a look at an example. I have a class of 30 students and I ask them 2 questions. Do you exercise regularly? And do you get a lot of sleep, 8 hours or more a night? So we'll draw a Venn diagram to illustrate this. A circle on the left, we'll label E for those regular exercisers, and the one on the right, we'll label S for the ones who sleep 8 hours a night. Those 2 circles should intersect. Make sure that happens and label your universe. So you now should have 4 pieces in this Venn diagram. There's the intersection, that's the footballish shape in the middle, and that would represent the people in the class who both exercise and they get 8 hours of sleep. The shape on the left that looks like a cookie with a bite remove represents the classmates who exercise but get less than 8 hours of sleep. Let's label those first two regions. Region 1, the football shape. Region 2, the cookie with the bite out of it that's on the left of the picture. Region 3, also a bitten cookie shape that represents the people who get plenty of sleep, but they don't exercise. And then outside of these circles, but inside the rectangle, would represent those who don't exercise and they don't get enough sleep. That's region, let's call it 4. So here's a problem to stop and solve. So we're still going with that class of 30, 20 of them exercise, 15 of them sleep 8 hours or more. So A, what's the greatest possible number of classmates who don't do either one of these good healthy habits? B, what's the greatest possible number who do both? C, what's the least possible number who do both? The easiest of these questions is probably B, if you want to do that one first. So again, stop the presentation and give this a try. Okay, so if I want to know the greatest number of people who neither get sleep or exercise, to make that as big as possible, I need to make the total inside the circles as small as possible. And to make it small would be to make a lot of overlap between the sets. Notice we can't make more than 15 do both because only 15 get 8 hours of sleep. So let's put 15 in the middle in the intersection region 1. The circle on the left, there should only be 20 people. You already have 15 of them in that football shape. So there's only 5 who just exercise and don't sleep enough. Now, on the right-hand side, that entire circle should have a total of 15. We already have 15 in the intersection. There's no more people to place in region number 3. So I now know how many people are in regions 1, 2, and 3, and I know how many people there are total. So we'll subtract. So 30, the total number of people in the whole rectangle, regions 1, 2, 3, and 4 is 30. Subtract the number of people in regions 1, 2, and 3. That leaves 10 people who neither sleep enough or exercise, and that's the biggest possible. The answer to B was 15. That's the most number who could do both because I can't have more than 15 because only 15 people get enough sleep. And then part C, suppose I want the least possible number who do both, sleep and exercise. We know that the sum of the regions in the whole shape is at most 30. That includes the outside, but we'll try to make that as small as possible. The sum of the regions in 1 and 2 is 20. The sum in regions 2 and 3 is 15. If we try to put nobody in the intersection, we would get 20 in region 2 and 15 in region 3. And there are only 30 students in the class, so we can't have 35 people. So we overdid it by 5. And that may tempt you to try to put 5 in the middle, and that turns out to be the right answer. But to make sure that it's really the smallest, you might need to justify to yourself why the answer isn't 1, 2, 3, or 4. And if you try any of those, you'll see that the total in the two circles, regions 1, 2, and 3, will be more than 30. So the answer is the least possible number who do both is 5. So that's it for today. We will practice more in class. Hope you're having a great Labor Day holiday. Thanks. Bye-bye.